Good morning and good afternoon to everyone. Welcome to the course Unlocking the Potential of Biotechnology in Food Production. This course provides an overview of the applications of biotechnology in the agricultural and food industry, exploring how it contributes to food security, creates economic value, and addresses challenges in the development of new varieties. The course also delves into the utilization of biotechnology in livestock, fisheries, the food industry, and management of agricultural waste. Together, we are starting with the module number 1, how biotechnology can contribute to food security. This course is organized by Obreal and the Federal University of Agriculture in Nigeria. Additionally, the Pan-African University will be certifying this training for all attendants fulfilling the requirements. I would like to thank all the organizations from Africa, from Latin America, and from Europe that have been collaborating to get this course done as experts and moderators. We have more than 1,000 enrolled participants from many different countries in Africa and in Latin America. My name is Jimena Estrella. I'm an agricultural economist collaborating with Obreal. Together with Professor Obadina Yehoul, we are coordinating this course. And in order to introduce Obreal to all the attendants, I would like to present a short video of our organization.
Obreal is an organization that promotes inter-regional dialogue, composed of higher education institutions, university associations, and cooperation agencies from all latitudes. We were born in Barcelona, a city that represents our values: innovation, inclusion, plurality, and multilingualism. We work to promote education and development with the conviction that through dialogue and connection, we can understand each other better and build a more just reality. In the world, there is not only one North or one South, there are multiple and different Norths and Souths. Our mission is to build bridges between different regions to encourage cooperation, exchange, and mutual recognition. We act based on priorities identified by local players and generate knowledge in a flexible, multilingual, and circular manner. Promoting interregional political dialogue, building capacities, and promoting critical knowledge of diverse realities. At Obreal, we think that development should come from the territories themselves and the people who inhabit them. Obreal is a cross-cutting, multilingual and interregional project that combines efforts to build shared solutions to the common development challenges shared by the different Norths and the different Souths. We must do it for ourselves, but above all, for the generations that will succeed us.
Okay, thank you. And now I will give the floor to Obreal's president, Professor Ramon Torrent, for some welcoming words.
Good morning, good afternoon, good evening, depending on where you are living. Buenos días, buenas tardes, bonjour, bon après-midi, bonsoir, bon dia, boa tarde. And please translate this salute in all other languages that can be your own. Translate it to Guarani if you are in Paraguay, to Swahili if you are in East Africa, to Dutch and Flemish, whether you are in Flanders in Belgium or in the Netherlands. I insist on this linguistic aspect for two reasons. First, because I'm an absolute ignorant on the content of this course. so I cannot say any reasonably meaningful and intelligent word on biotechnology. And at my age, I have learned to speak only on what I know and keep silent and modestly learning on what I don't know. Secondly, because this is a course, as the video just shown by Jimena tries to show, born from an initiative of interregional dialogue. And we believe that interregional dialogue between the different Souths and the different Norths in the world cannot use as vehicle one language, even if people think that English is the language of globalization. This is not true for two reasons. First, because it is not true. Most people in the world, and in particular most affected populations by problems of food and nutrition, do not speak English. And even second reason, because those that try to speak English do not speak English, but as I do, use bad English. And bad English cannot be the only language of globalization. As I often say, if you used to think about the problems of globalization in a bad language, don't be surprised that you end in bad thoughts. This is why Obreal Global is promoting an ambitiously modest project on artificial intelligence, multilingualism, multi-regionalism, higher education, and innovation. Because I'm very old and probably I will not be able to see it, but I'm sure that in 10 or 15 years, I would be able to speak in the only language in which I have a reasonably good accent, which is my Catalan, my small minority language in Spain, and I would be listened to in Swahili or in Guarani or in Dutch or in English or in French or in Portuguese. That being said, this is more than enough. I promised to Jimena that I would not be speaking more than 5 minutes. I keep my promises as far as possible. So this is all. I'm sure that under the guidance by Jimena and Adevale, you will be in much better hands than in my own for the implementation of this course. Welcome. Thanks for attending. Thanks for responding to this initiative by Obreal Global. Please go ahead. Good work. Thanks.
Thank you very much, Ramon, and thank all the attendants who are participating in the chat, greeting us from many different countries around the world, Africa and Latin America, and also from some other regions. Thank you all for being here, and I will give the floor to Professor Obadina so that he can introduce our two super experts that will delight us with the introduction to this course.
Yeah, thank you, Jimna. Thank you, Professor Ramon, and I also join the speakers before me to welcome all the participants. This afternoon, this morning, this evening, we have with us two professors from two different regions of the world, one from the Latin America and another one from Africa. And permit me to introduce the first professor that is going to take us through within the next 20 minutes, followed by the second professor. So the first professor is Professor Renata Reema. She is an independent researcher at the Institute of Agrobiotechnology of the Littoral, Santa Fe. She is also an associate professor and chair of cellular biology, Department of Plant Biotechnology, founder as well and scientific leader of Infura, all in Argentina. She is going to be the fourth panelist, and after her, we have Professor Ayotunde Olutumininu Adebambo. He is a professor in the Department of Animal Genetics and Biotechnology at the Federal University of Agriculture, Abeokuta. He has flair for teaching and training of youths in biotechnology and its impact on life. These are the two panelists for today, but we're going to start with Renata. Renata, the floor is yours. Thank you.
Thank you so much for the introduction. Thank you so much for the invitation to be here today. Today, we are gathered together to talk about food security and biotechnology. What means food security? Food security is supported by 6 big pillars. Availability, which means enough food of appropriate quality. Access, which refers to enough financial and physical resources to achieve availability. Use and utilization, which means the knowledge of an adequate diet, what that means. Stability is another pillar, which refers to ensure food security in the event of sudden shocks. Agency, the capacity of individuals to exercise a degree of control in their own decisions. And sustainability, which means that we need to ensure that the food needs of the present won't be compromise future food security. But today we know that food security is under stress, mainly because of climate change, global economic recessions, rising prices, and war. So in this context of food insecurity, biotechnology has started a revolution in the way we address this. Indeed, we know it has been demonstrated that biotechnology has a huge potential to transform human health, like for instance with vaccines, food production, and environmental conservation. But what means biotechnology? In short, biotechnology is an interdisciplinary field that merges life science, engineering, technology. Utilize biological system, that means living organisms or their parts, to create novel or improved product or processes. Indeed, biotechnology is basic on biology and can be considered as a branch of biology. Traditional biotechnology usually utilize the living organisms in their natural forms. But modern technology that was born in the 70s involves more advanced modification of the biological systems or organisms. That's because genetic engineering provides the new possibility to make change in the DNA, that very famous molecule. The most common and well-known approach in modern biotechnology to modify living organisms are 2 approaches, transgenics and gene editing. Transgenics, it means that a section of DNA, a foreign DNA, a DNA coming from another species, is inserted into the DNA of a target, for instance, crop or organisms. On the other hand, gene editing means sections of the plant DNA that are cut off. Of course, this has an open discussion of the good things that this approach have and the bad things. It's a huge discussion. Well, we need to, we don't have enough time to discuss the ethics and other things and social impressions, but it's a very nice discussion to follow up in another module. As a plant biologist, I'm interested in the biotechnology applies to agriculture to ensure food security. Globally, there are many approved biotech crops. In the ranking, first place is maize with more than 20 new varieties which has huge technology in it. Then it follows cotton, potatoes, soybean, and canola, among other crops. What are the improved traits to ensure food security? Well, people and research and companies have been working in improving the yield, so to achieve enough food. And then not only the yield, but sometimes the yield is accompanying with biofortification. So not only we have crops now that are high productive, but also we have crops that can offer fortification or more nutritious food, like for instance, the rice, the golden rice, which is an extraordinary example of a rice, high productive rice that also has a huge content of a precursor of vitamin A, which is helping to decrease the impact of several diseases. Another improved trait is the extended shelf life to avoid many waste that the industry has. Or nutrient use efficiency, for instance, improving roots of crops that make the crop more efficient in the use of nitrogen, avoiding or diminishing the leaking nitrogen effect. Other crops are biotic and abiotic stress resistance, like for instance, crops that are resistant to pests, viruses, bacteria, or are resistant to drought, flooding, or salt stress. We have many examples of those. And also the traditional herbicide resistant, the ones that are crops that resist the application of input or agrochemical to fight against weeds in the field. But what's going on in Argentina? The trending topic in Argentina in this latitude are the use of biotechnology to develop more sustainable crops. That means reduce gas emission, increase carbon sequestration under the practices, assure fuel security, and regenerates degraded soils. Our current crops are annual crops. That means they have short life, and they have to be sowing and harvesting many times along the year. This is a agricultural practice that has high cost for farmers, high carbon footprint, water footprint, a lot of waste, and it does not contribute to soil regeneration. In contrast, what happens if we build perennial crops, which are under development? We don't have the crop yet. Well, perennial crops will live longer. And with that, we will avoid the need to be replanted every year. This reduces about 50% of the cost of the practices the agricultural practices, the crop maintenance, the field maintenance. It decreased the use of machinery, meaning they reduce the carbon footprint, the waste, and the water footprint. And as the crops live longer in the field, they have better roots and they promote soil regeneration. But it's not that easy to convert an annual crop, commercial annual crops, into a perennial crop. We have to change the life cycle, the roots, the shape of the plant, and we need to be sure to keep the plant productive. There are 3 different approaches to be able to convert annual into perennial crops. The first 2, neo-domestication and traditional breedings, are based on traditional biotechnology. Neo-domestication means domesticate from scratch a new crop using a wild variety, a wild species. This is a long process that takes more than 40 years of development. Example of this is kernel, the perennial wheat developed by the States and Australia. Then we have another approach to get to perennial crops, traditional breeding. This is a long process too to develop this. It consists of crossing a wild species with a commercial species, like the example of new perennial rice developed by China and the States. And also, a novel approach is using the genetic engineering that more modern, that fit into the modern biotechnology. That has a lot of advantage. It takes only 7 to 10 years to develop the crop, and the technology can be copied in many crops. If you do neo-domestication or traditional breeding, you have to start from scratch every time you want to improve a crop. Genetic engineers allow you to copy the technology to many species. That's what we are doing in Argentina and in my company, Infira. But I wanted to mention that Infira's origin, I wanted to tell you how Infira was born. Infira was born in a university lab. We were doing a small lab doing research in a bench at Santa Fe, Argentina. So this is amazing because we are at the point where we were able to transfer the technology to a company to prove the technology into many crops. So it's a nice case of a study, a nice case of technology transfer from a bench university to a society. It's a long way, of course, but a take-home message for students or professors. My first message for them is that research at the university has a key role to play in transferring knowledge and technologies to society. But also I have a message for universities and ministers. They have to be prepared to receive the knowledge. And you have to have policies, enough modern policies, and also modern programs to help the transfer. So the science, the research, we do one part, but we need the support of others to do the technology transfer. But it's a very nice case because we were a small lab in Argentina, and we have now in our hand a technology that has a huge potential and wants to help to achieve a more sustainable agriculture. There are many issues and challenges and opportunity that biotechnology and applied to agriculture has, other fields too. But despite all the programs we have, and challenges remain in terms of regulation of these kind of crops and other topics, beautiful topic to discuss further. Accessibility, this new crops, new variety, new technology should be accessible for big farmers to minor farmers, to small farmers. And another big issue is social acceptance of this new crop that has touched, that we have tuned the DNA. This is highlighting the need for an interdisciplinary approach and effective policy. We need to move on to a more deep and modern discussions to take advantage of the opportunities that biotechnology allow us to have when we think in food security and modern agriculture practices. Well, thank you so much for your attention. You have my email. If you are very welcome to contact me at any time. I'm happy to take questions after the next talk. Thank you so much.
Yeah, thank you, Renata. I'm very sure that the participants have enjoyed your lecture, and be rest assured that questions are coming for you during the questions and answer session. We want to thank you once again for having you. Now we are moving to the next panelist, who is Professor Adebambo from Federal University of Agriculture, Abeokuta in Nigeria, Africa, that is going to talk to us for the next 15 minutes. Professor Adebambo, the floor is yours. Thank you.
So, thank you. I'm happy to be here. And I see that there are so many people from different parts of the world. I'll start sharing my screen. And greeting from my own end is Ekason, Ekabosurietoyi. I am Yoruba. Okay. So, I'll be talking more. Like I've always said, my drive is towards getting youth and the future of the populace into biotechnology. Okay, so my title is Unlocking the Potential of Biotechnology in Food Production for Youths. I believe the youths are our future. Biotechnology, the first part of biotechnology and unlocking biotechnology is getting biotechnology education in developing nations, and it remains one of the greatest limiting factors in achieving optimal human resource capacity to drive and tap the bioresource of these nations. We all know what biotechnology is. Biotechnology uses living processes and organism or system to manufacture products or technology intended to improve the quality of human life. Also, the southern part of the world, most especially the SSA, the Sub-Saharan Africa, have many countries that are situated in rich biodiversity enclaves. And in my own presentation, I would like to tell you my experience in Nigeria. Throughout my travels and my research and my growth through academic and seeing other businesses, I've always loved to domesticate what I see outside and domesticate it to Nigeria. But the following challenges are seen in application of biotechnology in Nigeria. First, we have a funding problem. There are high costs of equipment, reagents, research and development risks, and timeliness makes biotechnology products very expensive in this part of the world. And we are still struggling with these means and non-information. So there's a fear of new and unknown technology capabilities, ethics, social and environmental concerns all around. The third part is that the political will to push for biotechnology is mostly not seen. I would dare to say that most of most of the push I see from the polity in Nigeria is based on controlling and making legal grounds for use of biotechnology. I'm going to share a publication that summarizes what we go through in this part of the world. It's called Smallholder Farm and Biotechnology. It's by Ender Gabriel Carlson, Nico Barrier et al. It's titled Crop Biotechnology and Smallholder Farmers in Africa in a book called Genetically Modified Plants and Beyond. So I'm going to do a summary. You can always get this book. I can share it to you online. The major things that you find out that most African regions their mainstay in agriculture and not mechanized agriculture per se. Most smallholder farmers are more into indigenous and manual agriculture. But if you do check a trend of countries, and most countries that are into cereal production, you find that the Northern American are the highest producers of cereal per tons per hectare, yield tons per hectare. And you can see the growth throughout the years. Down below, you'll find, as usual, Africa, and you can find that there's not been more change in the growth of yields of cereal grains. Secondly, if you look at the yields of cereals and the land used to produce cereals, you find that in Asia, this is the yields of cereal in Asian countries, and you find the land use of Asian countries this low. But in Africa, you have land use and cereal yields almost very low. That means you find Asian countries producing more yields per hectare of land. The next slide will show you the reason for this. This is the investment per country into research and development into biotechnology. And you find that most African countries, you find that their investments into biotechnology research and development is quite low. While some countries like Zimbabwe, Mauritius are growing, the investment is quite on the increase. I think this states that in most countries, the more you invest into biotechnology, the better your yields per hectare of land. I summarize a quick solution that in order to bring biotechnology and improve biotechnology in Nigeria, we need to do one thing: small footprint modular devices which encourage government and private institutions, ease of courses, ease of ownership, and fast employment generation. Young people find such devices affordable, easily modified for personal development and stand alone. The young people are claimed to be on or underemployed, but they account for large percentage of our population. The youth do not perceive agriculture as remunerative or prestigious profession. We need to provide opportunities and attractive environment for them to self-challenge and create solutions. We also need tools that are challenging and tools that are playful tools, and tools that are easily affordable and manageable and modular. In my lab, these are the kind of tools I use. They are small modular equipment. They are easily managed and they are easily shipped and repaired. So these are the solutions I always push to youth. Okay. And also for education, from our own end, we always try and push youth education in different ways. And we've had some successes, giving them challenges and gifts. I'm going to do a summary of drivers of biotechnology, and they are broken into the following: government and government institution, government and international institution, private institutions and NGOs, and private companies. And throughout, you find most government institutions, especially with companies like you said, and IITA in Ibadan, has been able to produce so many products, agricultural products, tomato projects, newest rice, virus, varroa, cassava, herbicide, blight resistance, and so many different products in plants. In animal, we have my publication, which is Funab Alpha Chicken and Improved Guinea Fowl. And we have some other private organizations that are into biotechnology. So many of them, you can get it later on. I'm going to do a summary as this. There are many biotechnology companies in health and pharmaceuticals. If pharmaceuticals are exempted, most companies are into provision of services than products. Services provided includes genetics, diagnostic, research, parental tests, and educational training plus skill acquisition. Under agricultural biotechnology, we have more companies in plant biotechnology than animal. And most animal agricultural biotechnology companies do more of hormonal and anatomical reproductive manipulation than molecular and cell biotechnology. Intergovernmental rather than private collaboration seem to drive biotechnology business more in this area of the world. And lessons and prospects. Biotechnology can help African countries effort towards achieving social and economic development, contributing to the United Nations Sustainable Development Goals. The future holds program for the commercialization of GM products. Research, regulatory, and outreach capacity in modern biotechnology is seen as fundamental to the promotion of advanced science. Proactive, strong voice communication processes to identify needs, build awareness, customize capacity education for policymakers and farmers will help to maintain the current efforts in improving political dynamics towards modern biotechnology. And you get some of the cases of videos later on. We have one by a farmer, Sam, called Samson Ogwele. You can check it, and what IIT has been doing in our environment. I'll wait for your questions on most of these things as we proceed. Thank you.
Thank you very much, Professor Adebambo, and also Renata, for your general overview and introduction to the subject of biotechnology. We have enrolled participants, as I already mentioned, from different countries, but also from different backgrounds. So we have designed this session to be an introduction with basic concepts and some very good examples of how biotechnology can assess the issues of food security. Let me give you two important numbers to frame also these subjects professors have outlined, is that Latin America and Africa account for 25% of world population. And we know from these regions that we both face significant challenges in terms of food security. In Africa, the number of people that cannot afford a healthy diet is up to 399 million people, while in Latin America, that number is 130. So this is definitely a global challenge that we need to work for, and this is the whole scope of this course, that we can identify opportunities, means, projects, ideas, that we can work together between researchers, students, and companies from our two regions. Additionally, let me give you a number of small farmers, and the reason we need to work for them and assess their needs is that they account for more than 84% of world farms, but they only provide 29% of global production of crops for food, animal feed, and for fuel. So it is quite clear from basic numbers that all Renata and what Adebambo has teach us today is really, really important, and we need to focus our efforts on research, on training, or in our private activities, depending on our background and our area, but really to understand this global challenge we are facing. Let's give us, Professor Dabima, if you can help me, we will give some space for questions from the audience. Let me introduce the first one to Professor Renata. If you can tell us something about some studies on the impact of the introduction of crops improved by biotechnology.
Yeah, thank you so much. Excellent question. There are many studies on the impact of crops, modified crops around the world, especially crops that are commercially available, have a lot of information in it, a lot of research, and that support the safety of the crop. However, we need to think in the type of crop we are talking about. We have the first generation of crops that are modified or genetically modified, that are combined with input, meaning, for instance, herbicide. It depends on herbicide use. And we have a new era of biotechnology. Biotechnology can be used also to develop more sustainable crops that reduce the use of herbicide, improve soil, fix carbon. So we have now in the years where we can use and we understand the use of technology for developing a new generation of crops that do not depend on the inputs, fertilizers, agrotoxins, right? For instance, the perennial crops. If we think in annual versus perennially, nature prefers perennials. 95% of the species, vegetable species we know, they have the names and surnames, are perennials, and only 5% are annual. So the nature prefers perennials because it has a lot of environmental impact, a lot of environmental benefits. An additional thing is that the ancestors of our current annual crops were perennials. During domestication, we changed that because of many decisions, but for sure not because of thinking on climate change, for instance, right? So it's a big discussion on whether now we can use the technology to mimic what happened in nature. There are a lot of information of that, and when you read that, please be sure to keep separate the first generation of modified crops and the new generation of modified crop that have different goals. Of course, biotechnology, when you read the papers, I shared with the organizers some papers that are also helpful to understand this. But when you read the paper also, you will think, wow, biotechnology is like magic. It's so superb, but it's not magic. Biotechnology can solve some problems, but with that, new problems arise. So we have to keep in mind that biotechnology is not magic. It can solve problems, but we need to be prepared for new problems, right? Thank you so much.
Excellent. Thank you, Renata, for your complete answer on this tough subject that we see every day on a daily basis on the newspapers and on the media. So it's very useful that you can provide tips on how to read and how to prepare ourselves on this. Professor De Bambo, I have a question for you. Of course, both of you can answer, but specifically, Professor De Bambo, can you give us some light on how can we educate more people to understand and accept the bioengineered crops in our regions for smallholder farmers so that they can plant or use more of them? And I will combine it with the second question that deals with youth. And do you think youth has a special role on this?
I think presently the youth is the major driver of our society these days, especially with social media, internet availability, everything. We have so much information. Therefore, we need to carry the youth along. And when I started biotechnologies as a young student, people thought that biotechnology is for the old professors. People don't understand until people like us came out and said, no, it is not for the old professors. It is for your generation, the young people around us. Those are the people that can really change and make biotechnology go wide and near. And we need to educate them to let them know that there's no fear in biotechnology. In this region of the world, there's always been that information that was garnered from so long that, oh, GMO crops, GMO products are bad. But if you search, I've been searching for long throughout or in literature, then we have never, please correct me if anybody can, we have never had an incident where GM crops are biotechnological improved crops or animals cause a disease in humans. So presently in this area, we don't have a problem of GM crops causing problem. What we have is a problem of having food to eat. There are millions of people in the southern part of the world dying due to hunger. And the only way we can create a future where everybody has food to eat is when we carry the youth along. Unfortunately, like I said, most equipment, reagents in biotechnology are so expensive. Most of them are not domesticated for this area of the world. And you find that one of the things I learned is picking out smaller modular equipment. But no matter what we do, we have to educate the youth. And when we educate the youth, the fear of biotechnology will be left, will disappear. I'm looking towards a future where young people can carry out researches, improve crops, improve animals in their little classes, do researches, do improvement in their little classes. This is the future I see every day. So we can educate the youth. To educate the youth, we need to use equipment that is affordable. and is available to the youth. Case in point, there is hardly any young person that does not have an Android phone. There's hardly any young person. If the young person does not have it today, they'll be looking towards getting one tomorrow. So, and that is where they get educated. We have to have a group of people like O'Brien to start pushing education on net about technology. And like modules like this, start creating a ground where young people can see where they are into. But no matter what we do, there has to be a special funding. Most funding that go on to educate are funding that students will get funded to come and learn outside their area in Europe, in the West. We have to have funding that will educate not only the best of students in Africa, but all cadres of students. The first class students, the second class upper, even the third class student, and the secondary and primary school student needs to be educated if we want to remove the fear of biotechnology. Funding not only for the best of students, but funding for all cadres of students. Thank you.
Thank you, Professor. We are almost running out of time. I will ask Professor Obadina, who is the coordinator of this course, together with me. He's Professor of Food Safety and Biotechnology. So I would like to ask him to give some final words before I can give some technical pedagogical tips to close the session.
Yeah,
please,
thank
Professor.
you, Jimena. Thank you. Let me once again thank our panelists for today. They have done an excellent job. They have opened more in the area of biotechnology. I believe the participants have also gained a lot. And from the series of questions that are posted on the chat platform and on the Q&A, even though we are unable to answer all the questions, we believe that the materials that are made available by the professors will really help in answering many of the questions that were raised and more that are not raised today. We appreciate everyone that have joined today. We know that some people may have little challenge to join us today for this first module. We are going to continue in the series of the modules for this course. This is the first out of this among the 6 series. So we still have 5 more to go. And Jimena is going to talk on that. But to say that the recording of this will also be available, as some people are asking on the platform. So thank you. So I hand over to Jimena. Thank you.
Okay, thank you, Professor. And again, thank you, Renata and Adebambo, for this time, for the devoted time to prepare this session and to be today with us. As it was already mentioned, the recorded session will be uploaded on the platform together with the presentations, together with very interesting materials the 2 experts have provided us, scientific papers, videos, case studies. Both of them have a very interesting background in teaching, research, and private activity as entrepreneurs and startup directors. So I really thank you for your time. It's been really interesting to see you and to learn from you today. Thank you from the people from Brazil, Peru, Paraguay, Honduras, Mexico, Ghana, Nigeria, Uganda, South Africa, and many more that have joined this session. The material will be ready tomorrow. You will be able to see it during all the course. We are having our next session on bioeconomics on April the 25th. at the same time, with also two very distinguished professors from Africa and from Latin America. Thank you so much for joining and have a great day.
Thank you.
Thank you.
Bye, everyone. Thank you. Bye.